Okay, there's been a change of plans. Trainmaster does not get the Revolution 1. And the reason he cannot get a Revolution 1 is because I promised he could have a 280. I promised him he could have a 280. I already got a platform and everything. Because he's not a scale width hood. One of the few locomotives you can actually put a 280 in. Just barely. So, we're going to be able to test that along with them. Now, that means we got to bring in substitute. What else can we try it on? Well, you may have seen in several videos these two characters sitting right down the track over there. They've been sitting over there, right about there for a little while. Like a long while, like probably a couple years. These are two SD90s. There's a third one also. Okay, the third one is for sure Real Power Products. These, I don't actually know. It was once told me they were Kato. But, maybe they are. Who knows? But, one of them I got from my favorite junk man, and it's right there. Now, I don't know what's going on with this, but let's try it. I'm going to show you. Let's try this guy. Okay, so he's in DC. Not been touched, not cleaned or nothing. That's max power right there. That is maximum power. And he can't make it. Just doesn't have that motor does not do the trick. Plus, it's wired backwards. This thing is wired backwards. And doesn't stay on the track either, of course. So, I'm going to junk all this. And we're going to put the Revolution motor in it. Okay, so we're going to do two of them. This one here, I'm going to have to track down the rest of his parts. But this one was painted so long ago. I believe I airbrushed. This is Rust-Oleum red enamel that I airbrushed. So that's a while. I quit using it because it took weeks for this to dry. Because it was enamel. But that's okay. This one will get painted. That was going to get Blood Angel red, of course. Okay. That's the plan. We're going to do these two SD90s. I didn't really want this project to get that involved because it's July 1st and we have to get to laying track. We got some track building and laying we got to do in order to become operational. But anyways, so what's going to happen is the 60 is going to get the motor, and I already got his platforms made. So this platform will sit like that. There's a hole for a bridge rectifier so that I can do some constant lighting. And I got wiring holes and stuff. And I got a long space here to put the decoder and the PC board and all that kind of good stuff in there. Then I did mill this frame so that I'd make 15-inch radius. And then because of the way these things are set up, they are a shorting hazard. So everywhere you see green, that's liquid electrical tape. And I'm going to have to put some on the trucks too. And not because of the 15-inch radius, but because I notice it shorts anyways. When the trucks turn, the arm will touch the frame and it'll short. Okay. So now, this is what I got for you. Let us do some testing. Now I will put, there's the tester right there. Okay, and keep your eye on the tester. I got some different motors to test here. So first up, we're going to take the first Revolution, and it's already been tuned up, broken. and we're going to look at what numbers we can get out of it. Okay. I'm going to connect them up here at 1 volt. Okay, so he's turning. He is turning. Keep your eye on the numbers. Okay, I stalled him at 0.08 at 1 volt. But 1 volt, this thing has got some torque to it at 1 volt. Still turning. Now, what we're going to do, I'm just going to put the leads on here. I'm going to take the big bolt here. And we're going to basically hang this guy. We're just going to hang him off the workbench here, connected. And that's how I'm going to watch the numbers. We'll run a test. So the bearings have air tool oil on them. All right, now let's dial in. Let's dial in exactly. Let's go with 9 volts. And I'm picking 9 volts because that on my DCC setup, which is DigiKeis, I have the power set to 18 volts. So we're going to test all these motors against each other at 9 volts. There we go. 9 volts exactly. So we're drawing 0.033 amps. And I already know that I do not want to try to stall this. That's me trying to, that's the best I can do without, and burning my finger at 0.3 amps at the most. Then burning my finger. Okay. Now, you watch the final number back here. As the motor, I noticed as the motor gets broken in, it'll go 2 1 2 1 2 1, then all of a sudden it'll be 1, and it'll go 1 0 1 0, and the amps will drop as the motor gets better and better. Now I think I've already got them about as good as it should be, but it's at least good enough to operate. Okay, that's going to be our standard. 9 volts, 0.03 amps. Okay, roughly half layout speed. And we got a good clip going on here, and we got a lot of torque. And if I was to stall this out, it'll stall with the pliers at under, it'll be something like 0.8 amps if I grab onto the pliers, which I don't want to do. Okay, that's one. Okay, now, so that was our benchmark. Roughly 0.3 amps with the new motor. Here is a 280, and this motor has been run. Okay, so let's connect them so we don't have to oil the bearing. He's already been run once. I think he's been broken pretty good too. Let's connect him up. Whoops. Okay. The 280. Okay. The 280 is now running at 9 volts. Now this is a size 2 motor with a heat shield. And at 0.1, it burned my fingers. 0.2, and it very hard to stall. Very high torque, but look at the amps on the 280. Just a little higher than our Revolution motor. The 280 is an awesome motor. Make no mistake about it. It's a size 2. So it is a really, really good motor. Yeah, very, very good performance. Okay, now let's take, okay, let's do next. This is a Johnson 6-pole motor. It is almost, well, it's about size 2. It's roughly size 2. Now this one needs to be, we're going to do it without, this is without putting any oil on the bearings. Let's do that first. See what we got. Ooh, that thing is taking off. Now look at the amp draw on that. That's 0.12. Okay, that's like 4 times what the revolution motor's doing. About 3 times what the 280 is doing. But its RPMs are ridiculously off the chart. And so yeah. Don't try stalling that one with your fingers. I got it up to 1 amp and I wasn't barely even slowing it down. Okay, now that is untuned, untouched. So let's go ahead and modify it quick. We got to do our magic on it. We'll take our Tier 2 oil, and I just filled this today because when you go to the store to get this, be wise and buy the quart. It's like 10-15 bucks at the most. And the little bottle of this in a plastic bottle is like 8 bucks. So I refilled those. Okay, let's find our little screwdriver. Alright, now what we do is we take a little bit of oil, which is probably spilled all over the top as usual. You get a dot, goes on the bearing. Now, where were we at? 0.127? Okay. And a little bit for the back bearing. It's unfortunate. These Johnson motors are what I use in the Tenchoto brass. With the silicone shaft that goes across to that gear tower to that crazy under the truck drive system. Because these are great for brass, because brass is very, very slow to begin with, and it needs a lot of high torque like this has. This has ridiculous torque. Okay, now let's see what our numbers are going to show. See if we run them in. You got to hold them both up. You got to hold them both ways to get the oil worked in. It is possible to make a tiny mini lathe with this, with these little screw holes here, and you can mount it to a bracket. You can make a tiny, tiny little, like, LED polisher. Okay. Quiet it down a little bit. Now, since it's never been run before, we'll watch the amps just for a minute here. As you can see, okay, now we hit a 2. And as it runs in, it is going to start dropping. A little bit at a time. So we won't run it for like 10 minutes or so, but I bet we can get that way down. Now, one of the other things we can do with this too, we're going to do this. We'll put him at 18 volts. But look at this. Even at 18 volts, he's drawing 0.17. That's really, really good. You can see it working its way in. Let's take him back down to our 12. Okay, getting down there a little bit. So we let him run for a while. I think we get that down like 0.125, something like that. That's a lot. That is a lot more amp draw than our Revolution and our 280. It's a single shaft. You can't get them in dual shaft. It's just a single, and it doesn't fit a scale with hood. But it's great for brass. Now, this is the motor from a Spectrum locomotive that came out from something I remotored. Let's see what its performance is at, wait, not 12 volts. Oh, let's put that Johnson back on here. We were supposed to be at 9. What was I thinking? There, 9 volts. Okay, let's put that Johnson back on here. Let's just see one more time. What was he doing at 9 volts again? What was he? We started out at 0.13 something, 137. So I'm settle down. Now you see how he's working his way to 8. Now he's working his way to, nope, now he's at 1. There he goes. We could probably get that down, like I said, to 125, maybe even less. If we let that go for about 10 minutes. I think he's gonna make it. And he said, "Oh, I made it." Okay, and he's gonna keep going. He's gonna keep working in. So that's good to go. This is a very, very good one. Still at 0.125 amps. That is really, really good. Now let's put the Bachmann Spectrum on here. 9 volts. There's our Spectrum. And I stalled them. There, I stalled them out at 9 volts. So he's pulling 0.44. That's not bad. He's slow and does not have the torque that the others have, because I can pitch it with my fingers and stop it just like that. But hey, on the stall, that's perfectly acceptable. It's well under the limit of 1 amp, and they'd say 1.5 amp, but 1 amp. But I can stall it, and it's not hard to do. And I think we could run him down. Well, let's see what happens. We'll give him a little dot of oil here, and we'll just see. Even though I think he's probably already had it, and I don't think it's going to make that much of a difference. But let's see. Oh, yep, we made a little difference. He goes, probably going to make it to 0.035. We let him run in. Maybe. Okay, that's the Spectrum motor. I don't know what the newest one is like, because I have not tried it. Now, here is a motor that may look familiar, only because motor housings are standard. So our Revolution motor housing is the standard size 1, length 8 motor housing. It's the inside is all custom and the shaft is custom. This is my version of this. This is the 24 volt version, which is a rear view mirror motor, or for a car that is out of production, and this motor is out of production, never to be seen again. That's why you cannot get these. Now, this housing and this setup has been around since I took apart an Atlas RSD12, and same housing. This is the 24 volt version. This is not the 12 volt that comes with most model trains. Alright, he's a little noisy. This is the 24 volt one. Oh, he's got a little torque to him, and I haven't used him yet. I can pinch him up and pull it at 0.7. He hasn't ever been used, so he ain't been tuned up. Let's give him a little bit of hurl. Yeah. See, this is a 24 volt version. Give him a little oil there. He likes that. And he may or may not work his way any farther. Okay, so he's drawn. Now, the difference is the Revolution's drawn 0.03 something. This is drawn 0.04 something. That's because this is a 20-year-old motor. It may not have been made 20 years ago. It's probably made like 7 or 8 years ago. And that was the last run of them. But since then, the machines that make the motors have gotten better. All right, so he stalls out 0.7. Pretty good. It's a decent motor. I don't have one of the motors. I'll try to find that motor out of that Atlas that we did. That C30-7 that we cannibalized to find out how to scratch build the 280s. Now, what I have for you now, this is a brand new face ripper. This is a 266, 24 volts. Actually, I think it might be even 29 volts. Okay, so we have to assemble it. You can choose if you want it in the ends or in the top. I think we're going to put them in the end. And they fit in these slots. If I can do that without breaking it. Maybe that's why I usually put them on top. Okay, so we're going to assemble them. So you've got fresh from a bag. Oh man, I bent it, of course. All right, forget it. We're going to put them on top. Just because it's easier. Okay. Let's get that guy in there. Hold on, we'll get him. Come on out. There. Oh, really? Really? I got it. There. That's one. Now this is what is in Hercules. Hercules has 2 of these wired in parallel. It's a size 2 square. Untouched. Let's try my 9 volts. Then we'll try putting a little. See that? Untouched. You can't even hear them. Oh, you can't stall them either. Nope, you're not going to be stalling them at 9 volts. That's just not going to happen. Okay, you're untouched. But single shaft only. Let's give them some Earl. Yeah, well, they're great for dual motor DD40. And they only get, there is no shaft in the back. It's sealed. Okay. There he is. You can't even hear him. He's holding steady. .03. And this is really powerful. But you can't get a size 1 motor like this. You need to go up to a size 2 if you want something like this. And there ain't nothing like this one. Say at 19 volts. 0.7. Okay, that's like slightly more than max power on DCC. And it's basically silent. And when you use the goop to attach them, they're silent. Silent motor. There, that's me trying. I'm not going to pinch him. It's not as fast as the Johnson, but unbelievable torque. And he does this. That's me stalling him, and I'm not stalling him. Still turning. Less than 2 volts. That's pretty amazing. That's why I love these. But they're single shaft, size 2. They don't fit everything. So now let's go back to our Revolution motor. And let's check them at 1.19 volts. So now he's pulling a 0.02. This is me trying to stall him. Still turning. Still turning. There, stalled. 0.14. Okay, so he's turning, and he's turning with some good torque, too. That's me sticking my finger on the end, as you can see. Turning. Now that is good stuff. We'll find some motors to compare this to, and I think that's going to be what we're going to do. Is we're going to have to find some way to tame these guys. Their mechanism is dubious. Not only is it dubious, but look how long a shaft that's going to be. Oh man, look how long a shaft we'd have to put in here. Now we know that we can do this with silicone hose because we did it on tunnel motor. I'm going to have to say I'm thinking of maybe we might put a rod inside the silicone or something. I don't know. I mean, we can make it work, but we might do something like with a rod in there, and then we'll see. We've already seen that the motor that's in there right now, which does look to me very much like, I don't know, it looks like an old Atlas motor, but I know it's not. Because it's too new and it's got that single flywheel on it. And I'll have to take that out and see what it is. But it's, I don't know, junk is what it is. We're going to fix it. And we're going to make it work. Well, there he is. That's what I got for you now. And we're going to keep working on it.